So there's a rhyme you have to learn off. Okay. And this rhyme is only used for right angle triangles. Everybody understand? So first of all, the hypotenuse is always the longest side. The angle always, the largest 90-degree angle always faces the hypotenuse. Everybody got that? The angle you're using, which in this case is angle A. Angle A is this angle down here. And what does A look directly at? It looks at this side here, which is now called the opposite sides. And then the last side is what, guys? The adjacent. Now, for argument's sake, if I now create an angle B, what side is opposite angle B? The one that was adjacent to A. So this one would actually be opposite B. And what does that change this one to? Adjacent to B. We all cool with that? All right. Next thing. The rhyme I have learned off is silly old Harry faced a horse through our attic. Some people learn it off as Sokotoa. You ready? So here's how you use it. You have three choices. Okay, your three choices are sine, cos, and tan. Everybody see the three highlighted letters? So if you're using sine, you're using opposite divided by hypotenuse. And that's where O and H come from. You're using opposite divided by hypotenuse. Likewise, for K, you're using adjacent divided by hypotenuse. Just that one there. And finally, for the last one, so I'll run out of colors here. For tan, you're using opposite over adjacent. Have you started this before? You've used it before? We hope so. Right. Now, that brings me to the following types of question. Right. And you'll get a bit of revision on this later. Right. First of all, I'm going to set up three sides. Okay, you ready? This is A, this is B. This is going to be 10, 8, 6. Okay. Which one's the hypotenuse? Nope. There is no hypotenuse because I never specified that it was a 90-degree angle. Could have been 89 degrees, could have been 90.1 degrees. Unless it specifically states that it is 90 degrees, there is no such thing as a hypotenuse, an opposite, or an adjacent. Everybody got that? So that's it. That's a trick question to start us off, all right? Now let's begin. All right. I'm going to write this rhyme on the top of the board. So Katawa, happy days. And what we're going to want from you is the following. What's sine A, cos A, tan A? What's sine B, cos B, and tan B? I'll tell you what, I'll give you one of the answers, all right? Cos A is what, guys? Adjacent over hypotenuse. Okay, which one's the hypotenuse again? 10 on the bottom. Opposite A is what? 8. 8 is the opposite, so I'm not going to use that. So what's the adjacent? 6. And the answer, therefore, will be 3 over 5. All right, guys, that's sine A. Opposite A is 8, so that first one will be A over 10, which is what? 4 over 5, okay. Next thing you're looking at is tan A, which is what? 8 over 6, which is 4 over 3, happy days. Sine B. So opposite B is 6. 6 over 10, which is 3 over 5, yeah. Cos B, which is? And finally tan B. 6 over 8, which is? Okay, got to pause there. Here's a try. So, what do we get? Okay. All right, fair enough. All right. Opposite x is 3. Hypotenuse is root 10, half to the longest side. That means for this sake, that would be the adjacent for the first angle. So, what do we get? 1 over root 10? Oh, no, for cos x. Yeah, so sin is 3 over root 10. And tan is 3/1, which is just 3, isn't it? Okay. Now, when we're talking about angle y, we're talking that number 1 is now the opposite. And number 3 would be the adjacent down. So it's just reverses around, doesn't it? 3/√10 and what else? 1/√10. 1/3. Now, have you noticed the crisscrossing that takes place? That that always happens when you change angle in a right angle triangle. They just switch around. Is that right? That happens in all right angle triangles. Happened in the last question as well. Now, next thing. Okay, we're not going to go near that for a minute. All right. Next thing, very easy, all right? First things first, can you use a calculator? Now, very important. One thing is ridiculously important here. When you zone in on top of your calculator, there can be 2 letters up there. It's either degrees or radians, okay? Make sure that all your calculators have the letter D. If it does not have the letter D, go to Shift, Setup, Angle Unit, and you have a choice between degrees, radians, and gradient. You're only ever going to use 1 or 2. We're going to stay with degrees, number 1. Is that okay? One more time. Shift, Setup, Angle Unit. Make sure everybody's in degrees. Okay with that? Do you have the older calculator? There we go. All right. Here's this relic of the past. It does look better. It's like an old Ferrari or something. It just looks better. But now, guys, look at this. All right. So what we have here is we go Shift, Setup, and look, it's actually in the initial menu. 3 for degrees or 4 for radians. You select 3 for degrees. Out of interest, how many people have this calculator? All right. Right. That's all right. It's a good calculator. Now, here's what we're going to do. Right, gents. First thing we're going to do is we're going to find out what tan 28.4 is. Let's go for tan 28.4. We got 0.507. Have we got 0.507? All right. 5407. Cool. Right. Next one's different. The next one wants you to do 43 degrees in 24 minutes. So you have to do cos 43, press the degree button, then press 24 and press the degree button as well. On this calculator, it's below the square root sign. On the newer calculator, it's still below the square root sign. Yes. Yeah. Who got 0.7266? Okay. We'll do one more. Time 30 degrees, 36 minutes. That's what we got, 0.5914. Everybody cool with that? All right. Now, I want to try to explain these questions in a bit of context, okay? So, is everybody right with this? Now, do you see this number here? 0.7453. Yeah? If I put that into the calculator, it'll kick back out 7,453 divided by 10,000. Everybody see that? So, because it's sine, okay, does everybody see sine? Sine is the opposite and the what? Sine is the opposite and the hypotenuse, isn't it? So look at this. Ready? Look at this. So that's 7,453 divided by 10,000, right? And sine is, everybody looking for this? Sine means opposite over hypotenuse. So, now really quickly, here's what happens. If I wanted to draw this angle exactly, I'd need to use a 10,000. Doesn't matter 10,000 what. Could be 10,000 millimeters, could be 10,000 kilometers. And Sean, it'd be 10,000, and the opposite would be 7,543. It would be a right angle triangle, and this would be angle A. Now, to find out what angle A is, what we quite simply do is the following. We use what are called the inverse functions. So you press Shift, sine inverse, yeah, and you use 0.7453. Everybody got that? And it tells you what angle is caused by this. It's an angle of 48 degrees. 48 degrees, is that right? So lads, for each and every one of these questions, if it's tan, tan inverse. If it's sine, sine inverse. Do you got it? So how'd you do part 5? How'd you do part 5? Just tan inverse it. No, you don't even have to do any of that. Just tan inverse 0.82888923. Just lob it into the calculator. And it should kick out the angle for you. To the nearest degree. Who got 42? Okay. And the last one. You need a calculator? Alright, you alright? Who got sine inverse point two? What you got? Sine inverse 0.1232. Who got 12 degrees? All right. Now, let's do this in context. Ready? So here's what's going to happen next. Okay, got it. Now, for argument's sake, here's a triangle. Everybody looking? Here's a triangle, okay? And the triangle is an 8 and a 6 triangle. And this is angle X. How would you determine how to find out angle X? Okay, the first thing I'm going to ask you is, what two sides do you know? You know the opposite. How do you know the opposite? And then it's not the longest side, is it? So it's adjacent. Lads, please pay attention here. Don't lose you right to start the chapter. Especially when you should know this stuff from June start, all right? Now, next thing. Which function should I choose? Sine, cos, or tan? Why am I choosing tan? So you have tan x equals 8 over 6. Yeah? So I want you to tan inverse that now and tell me what angle it is. What'd you say? 53 degrees? Yeah, grand. All right. Now, lads, here's what I want to teach us next. Okay? Does everybody see the old? Everybody sees the old triangle here, yeah? And here's what I'm going to do now. I'm going to double this triangle. Okay? What I mean by double it is, actually, I'm just going to double its length and its width. Okay? So when I double its length and width, oddly enough, here's what's going to happen. Double its height. Double its width. What do you know is about the angle? The angle stays the same. So if this is 12 and 16, it's now tan x equals 16 divided by 12, isn't it? And what is 16 divided by 12? It's still the same as 8 over 6. Everybody got that? So would everybody agree by grabbing two of the sides and doubling them, we actually didn't change the size of the angle whatsoever. Does that make sense? Right. Next thing I'm going to do, if you're looking, I'm not going to double the size of the both sides. I'm just going to double one of them. Ready? Everybody see the 6? The 6 stays the same. Everybody see the 6 staying the same? Okay. But what I'm going to do is I'm going to double the 8 all the way up to 16. What do you expect to happen to the angle? The angle was 53.13. Does doubling the height double the angle? Yay or nay? It can't because it'd have to be over. It'd be 106 degrees, wouldn't it? So doubling the height does not double the angle. Everyone cool with that? All right, get the new angle for me, will you? You're going to use tan again, aren't you? 16/6, yeah? Tan inverse it. 69.44. Is that all right with you guys? So, what we've learned there is doubling the size of the triangle does not affect the angles. Doubling one of the sides doesn't double the angle. You just get just a different answer. So trigonometric functions aren't scalable, is what we're trying to learn there. Is that just because you double the length doesn't mean you'll double the angle. Okay. So let's look at this one, right? Really quickly. How do you figure out the angle of cos theta equals 3/5? Now, if I was to draw that, you don't have to draw it, but what would it look like? So that's 3. Adjacent is 3, and hypotenuse is 5. And you're finding this angle here now, aren't you? How do you find that angle, lads? What's the button you press? Cos inverse, and what happens then? Yeah, cos inverse 3/5. What you get? 53. All right, lads. Homework's on Google Classroom tonight.